Hi, welcome back. What you're looking at is a geometry game that we built throughout the previous sections. So this is a complete code. If you don't have it, you can find this .py file attached to this lecture as a lecture resource. So let me go through this code quickly so I make sure that you know what it does, even though I suppose you watched the previous videos. Anyway, so here we are importing this randint function, which will generate some random numbers, random integers for us. And then we have the class point, which has an x and a y. And then it has this method, which gets as arguments a rectangle object instance. So an object instance that is supposed to be created by the rectangle class. And this method checks if these coordinates fall within the bounds of the rectangle. This is the conditional block that does that checking. So you see that point 1 is an attribute of rectangle of that instance. And you will see that down here, point 1 and point 2 are actually instance variables of the rectangle, so attributes of the rectangle class. Therefore, they become attributes of a rectangle instance that will be passed to false in rectangle when that method is called. So the rectangle has an area method as well, which calculates the area of the rectangle, right? And then here we generate the rectangle instance using some random points. Now I'm going to increase the range of the random numbers here, so I'm going to say 0 to 400. 0 to 400, so we get more variety and also increase the chances of not ending up with very small rectangles in the canvas. So these are the diagonal points of the rectangle, one point and the other point in the other diagonal extreme of the rectangle. And then we print out the coordinates of the rectangle, letting the user know about them so they see them on the command line. And then we get from the user, we get an input here, so an x coordinate, and we convert it to float, and we provide that as an input to point. So that value there, that float, will go and replace x here. The first coordinate, and the second coordinate will replace y here. So those two will be the coordinates of points. So that is a point object instance. And then we get from the user also the area, how much area they think the rectangle has, so a part of the game. And then finally we print out this string together with the output of the false in rectangle method, which gets as input this rectangle as we talked about, so rectangle instance, which is generated in here, and that returns true or false depending on whether that user point is inside the bounds of the rectangle. So true if it is inside the bounds, false if it's not. And we also print out the difference between the actual area of the rectangle calculated with this method and the area that the user declared. Right, now our next task is to draw the rectangle on the canvas. The object here is a rectangle and draw should be the method. So we have to add a draw method to the rectangle class. But that wouldn't be the best solution. It's not the best practice to actually modify your classes when there is a possibility to extend them. So instead of messing up with your existing classes which work well, you can instead extend the rectangle. So we had this rectangle object type, which creates imaginary rectangles. Now we want to create maybe a GUI rectangle class, which will be the actual graphical rectangle that we see on that canvas. So we have another object has surfaced in our program. You can call it GUI rectangle or graphical rectangle or turtle rectangle, whatever you like. I'm just going to call it GUI rectangle, so graphical user interface rectangle. And that now should subclass rectangle. Or in other words, GUI rectangle is a child of rectangle. So GUI rectangle is a child, rectangle is a parent. So we're talking here about inheritance. In other words, GUI rectangle inherits from rectangle. And that means GUI rectangle will have all the attributes of rectangle. So it will have these point 1, point 2. So it will get the entire init method for itself. And it will have this area method as well. Plus, we can add other methods. And in this case, it would be a draw method. So again, GUI rectangle is a class that has these two methods, plus it has this draw method. We're talking about an is-a relationship. So GUI rectangle is a rectangle, plus it has this draw method. So draw, what does draw need as input parameters first? This is the first thing you want to think about when you create a new method. So draw will draw a rectangle on a canvas. What do you need for that? Well, you need the coordinates of the rectangle, right? Which we already have. Self point 1, self point 2, and each of them has this x and y inside, so we have the coordinates. And we also need the canvas. Therefore, let's write here a canvas parameter. And for now, I'm just going to comment out everything here and just do some simple calls for now. So create some object instances. Let's say GUI rectangle is equal to GUI rectangle. So instantiate it. Point 1 and point 2 needs to be passed as parameters. So let me copy them from here and paste it in here. And don't forget to remove that hash. And so this is the instantiation of GUI rectangle, right? And then we want to create a canvas instance as well from turtle. So let me import turtle here. Import turtle. To create a canvas instance, you need to do canvas, or let's call it my turtle, equal to turtle.turtle. So that creates a canvas instance. And then we want to call the draw method of GUI rectangle, and we pass there the canvas instance. You see, canvas is a required argument. So you can either say canvas is equal to my turtle, or directly just do my turtle. Whatever you prefer, there are no hard rules for this. So some people prefer it to do like that because it's more readable, it's more explicit. So let's keep it like that. Right, we're doing well, but we have to finish the draw method here. So once we get the canvas, so once we get an instance of my turtle, then what we could do is we could apply all these. So let me copy them just like they are and paste them in here. All right, but now we have to change two things from this draw method. The first thing is that you see this canvas parameter is in gray color. That means that parameter, that variable, is not being used inside this function. Because when you have a parameter there, it means that you want to use it in your function definition or your method definition. So you can see that when you hover your mouse here, PyCharm is also saying that parameter canvas value is not used. So what is canvas? Well, canvas is actually my turtle. So you see down here that GUI rectangle.draw. So the draw method gets my turtle as the value of the canvas argument. So therefore now we need to replace my turtle with canvas everywhere. Right? But don't replace turtle, because turtle here is the library and my turtle was the instance of the canvas of the turtle. So that was one thing we needed to change. And the second thing, of course, is that these now are dummy data. So 50, 75, just some static numbers. We want to make that dynamic, so we want to get the origin of the rectangle from point 1. So here we would have something like self.point1.x and self.point1.y, right? And then we would have to go forward. So that would be the distance between the axis of point of the next point and point 1. We will do that in the next video. So we will implement that in the next video. For now, I just wanted to let you know that what we are about to do, so you understand things. And also I wanted to point out that you can see now that GUI rectangle has access to self.point1.x. So point 1 was an attribute of rectangle. You see, we declared it here, and we can use it from GUI rectangle, since GUI rectangle is a child of rectangle, so it inherits everything from rectangle. So let's leave it like that for now. In the next video we will go through that step by step. And so GUI rectangle inherits so GUI rectangle inherited this instance variable, so point 1 is an instance variable, point 2 is also an instance variable, but GUI rectangle also inherits the methods of rectangle. Let me prove you that. Let's say GUI rectangle dot area. Let's print it out and execute the program. Run geometry underscore game. Alright, so this is the output. So this was drawn by the draw method. These are all these data here, the dummy data, so to say. And when I close that, we get this number here as well, which is the output of this line. So that is the area of that particular rectangle. So a rectangle generated with these random coordinates. And that is the proof that a child is just an extension of the parent, so it does extra things, which in this case is the draw method. I hope inheritance is clear, and let's do some more practice in the next videos. Thanks.